Welcome to Cisco Tech Beat, the podcast that explores the people and stories behind what inspires the newest innovation. I'm your host, AB, and I'm really excited for today's episode, where I get to chat with Cisco Fellow, VP, Head of Engineering, JP Vasseur, who just happens to be our leading inventor with lots of patents to his name, spanning tech areas from machine learning and AI and security to the Internet of Things. JP and I have been working hard on making this episode happen, so I'm happy to finally be able to say, welcome to the show, JP.
Thank you very much, AB. You're not the only one excited about this discussion.
I know. It was months ago that we talked about making this podcast episode happen, and sometimes things get postponed, but I'm really happy about this happening today.
Likewise.
Now, we will talk a lot of technical stuff and really fun stuff, but before we get into that, I kind of want to talk about your journey to Cisco, because you started your career working for service providers. What was the nature of your work back then, and how did that experience lead to your decision to eventually join Cisco?
I was a young engineer. My first job was for cable and wireless, and I was so proud because, I just finished my studies and I knew quite a bit about the theory. And the first job, they gave me a screwdriver and they said, look, you're going to fix the voice and you will basically be very much hands-on. I was so shocked, but that was the best way to learn. Then I joined another company doing what we used to call facility management. And then I joined CGTEL, that was the second service provider in France. And that was an amazing, amazing journey for a few years. And then at some point, I thought, well, why not join a company like Cisco? Because there was so much to do. That was almost the beginning of the internet when I think about it. And then I can tell you the journey went through so quickly. And it has been 25 years.
Wow, 25 years. I mean, that's pretty impressive to be able to say that you've worked for a company for that long, right?
Oh, absolutely. And what matters, and I've got this question sometimes, from people, and usually what I say is, look, I spent 3 years doing some consulting engineering work for service providers when I was in Europe. Then I moved to Boston. I was in charge of MPLS and traffic engineering for about 7 years. Then I decided to move to the Internet of Things. At the time, it was John Chambers, the ex-CEO of Cisco, who suggested me to do that. That was, again, absolutely fantastic. And then I kept moving on to security and then, Wi-Fi. And then finally, what we're going to talk about today, which is about predictive networks.
Now we get into the fun stuff. And speaking of that, you are really the mastermind behind a team that created this incredible technology we're calling predictive networks. Just for anyone listening, what is predictive networks? Why is it important? And what kind of impact will it have on customers and businesses in the years to come?
Yeah, thank you for asking this question, because that's really at the heart of my job, which is about disruptive innovation. And maybe the one thing I like to say before we talk about predictive networks is to thank my team, because you mentioned my team. And I really believe that you can be as bright as you want. You can't do anything with a team. And I've got an extraordinary team with a lot of people like Gregory Mermou and P.A. Saval, and I could go on and on. But I wanted to acknowledge that, right? Because it's so important. Now, let's talk about predictive networks. Actually, it's very simple to explain. The technology behind it is fairly complicated, but the way it works is as simple as that. When you look at the internet, right? The internet, AB. We've been so fortunate to be part of this journey and building the internet at Cisco, but we've been in a reactive mode. So what does that mean? It means that you try to detect issues as quickly as possible. You detect the issue, then you move the traffic to an alternate path. And that's the job of what we call routing protocols and multiple recovery mechanisms.
Right.
But we thought, it was back in 2019, after almost a decade of work on machine learning, artificial intelligence for networking, we thought, well, maybe we can use this amazing technology to predict an issue before it happens, which sounds crazy when you think about it, right? At the beginning.
Yeah, for sure.
Right? But, that's really at the heart of machine learning, to be able to predict using some models, mathematical models. And that's exactly what predictive networks is about. So if I had to summarize in 30 seconds, here is what we do. We learn based on a massive amount of data. We build a model of a world, which is the internet in our case. And then what we do when the algorithm is fairly confident about an issue coming up, what we do, we proactively, potentially reroute the traffic onto an alternate path. This is as simple as that.
Got it. So it's really changing your approach to how you deal with issues in the network rather than just reacting to something. You lose a connection. Now you figure out where it's lost and you're kind of trying to put a Band-Aid on things. This is using machine learning to communicate constantly and develop a practice of identifying something that may cause an issue so that you can take care of it before it actually happens.
That's exactly right, AB. And you know what I would say is the ability to predict is based on the fact that we can learn. And
Right.
what makes me so excited about this technology is that when you think about it, that the first time we are enabling the ability to learn for networks. And we never did it in the past when you think about it. So what does that mean to learn? Well, it simply means that suppose that you have an issue every day at 5 p.m., for example. I can tell you that these days with the current technologies, every day at 5 p.m., you have the same issue because it's a seasonal issue, and then you break, and then you reroute the traffic. That's not what we do with predictive networks. What we do, we learn from the past. And so you really have the ability to learn, and because you learn, you can start predicting. And that's what is so exciting about it, is the ability to learn from the past using massive amount of data that we have at Cisco. And then based on that, you can start predicting. Isn't it exciting?
It's amazing. And it's interesting when I talk to fellow Cisconians about innovation and really about anything that Cisco is doing. The ultimate goal is to make the end user, the customer, have an incredible experience. And I imagine that with you and your team, it's not just about doing an innovation for innovation's sake. It's how can we actually make this technology better for the end user?
AB, you're making my day. Let me tell you why. But seriously, I want to tell you why. Because I'm known, by folks I'm working with as a little bit sometimes too obsessed about the customers, our customers, and the use case. And what I love to say is that what can kill technology is sometimes the passion for technology. So let me explain what I mean.
Okay.
For me, a good engineer is not someone that is using the technology as an end, but as a mean. And I always, for all of the projects that I managed to lead at Cisco, I always started with the issue to solve at the beginning. If it turns out that you need to invent a new technology, let's do it. And of course, we love technology at the end of the day, but the goal is not to invent new technologies for the sake of inventing technologies, is to solve a problem that was not solved before. And that's exactly what Cisco Predictive Networks is about.
Right.
Because we never did that in the past.
Wow. Yeah.
Right?
I love that. I mean, that makes sense. I think that's part of the culture of this company, and it's why so many people stay for such a long time. I'm curious about predictive networks itself. How was this idea born? How did it actually come to be?
Yeah, AV, that's an interesting question. Let me tell you why. Because first of all, what I believe is that my job, being a fellow at Cisco, is to figure out what are the most important problems to solve for our customers,
right,
and anticipate. It's all about vision in the end. If you don't have a vision, you cannot do any disruptive innovation. So I had this idea about the ability to predict, and maybe I can share with you, right? I know we have quite a few folks listening, but what happened, and that's really the truth, right? It was a few years ago in a meeting that I had with Chuck Robbins, our CEO, who loves technology. We sat down and I just say, look, Chuck, I'm not sure that I will succeed, but I want to introduce you to this new concept for the networks. And of course, we went back and forth together.
Sure.
We had a very open discussion. And as I said, we have we're lucky enough to have a CEO who is listening to his fellows, who loves the technology, who wants to innovate. And so without Chuck buying into this concept, it would have gone nowhere, because at some point you need to have resources, you need to have the power of Cisco to make it happen. So this is thanks to Chuck, if we are where we are with predictive networks.
That is amazing. I say this in every podcast, but it pretty much reconfirms my excitement about being part of the Cisco fabric, because our leadership is so accessible, they're extremely transparent, and they're very fair. And I think having the ability to talk to somebody at the highest level who is supportive of something that you're undertaking, there can be no greater feeling of support, right?
That's exactly right. And this is true for many members of the top leadership at Cisco. I have regular interaction with our CSO, Lee Santoni, with other ELT members. And, it's always scary when you start mentioning people because you don't want to forget anybody. But yes, it's part of the culture, right? It's part of the culture. You can have access to that level of leadership and build up something together, which is absolutely amazing.
That's right. It's funny we're talking about innovation because I've had conversations with people who drive these new technologies and new systems, and I know that there's this idea that failure is necessary to be able to make gains in terms of what you're working on. But I do remember this conversation that you and I had when we first met months ago, where you were saying that failure can mean different things depending on where you are. So, for example, in America, we often hear the proverb, if at first you don't succeed, try again. But you were saying that failure is defined in America might be quite different than how it may be defined where you are in France, for example. Would you mind expanding on that thought a little bit?
Yes, and I know this is a podcast, so you guys don't see me, but I do smile as we speak because
You do.
yeah, but you know why? Because this is so important, and you are absolutely spot on, AB. If you typically in France, for example, we don't have a strong culture for failures, and I do believe that you cannot really make disruptive innovation without failing. First of all,
Right.
Second, you never know whether you are going to succeed. So it means that you need to be very resilient and you don't know how much time it is going to take. And the biggest success we had over the past decade was a project that we never managed to conclude and to finish because it was very hard. And we've been pursuing this avenue. And each time we learned something.
Right.
Of course, when you start with a problem and you can solve it immediately, it might be that, the problem is too simple. And that's great. If you solve a problem, you're happy to go, you ship a product, and that's great. But if you look at predicting the future, which we know is, of course, extremely hard to do, you know that when you start, you will have to investigate many avenues. You will have to fail fast. And that's why maybe it's a terminology issue because when you say fail, by definition, it looks pejorative. And that's not what it means, right? It's just that, you just tried something that did not work. And what I asked my team to do over the years is to build cookbooks. When you write a thesis, for example, it always works, right? Whatever. I've never seen a thesis where you read the PhD thesis and you're like, oh, at the end of the day, the conclusion is, too bad. I spent 3 years and nothing worked. Too bad. Too bad, because we can learn so many things based on what did not work. So when we do cookbook internally, I keep saying to my team, explain also when you tried something, and for some reason, it was not the good avenue because we managed to learn from it. And you're right, in the US, that's something that is unique to this country, is the culture of trying and being an entrepreneur. In a country like France, it's not exactly in our culture. So maybe it's going to come at some point, but that's not yet the case.
Absolutely. No, totally makes sense. And, words often mean different things in different places. So looking at the flip side of quote unquote failure, I wanted to just touch upon some of the innovations you've invented. Would you mind giving an example of one and maybe how you think it positively affected people's use of the internet?
Yes, thank you, AB. That's a great question. So I managed to do a few things that without looking arrogant, hopefully, I would mention. The first one is probably the path composition element. And that was a new way of computing path for service providers. And it's always a great feeling when you look back and you see that this technology has been deployed in hundreds of networks. And then, I decided to move to the Internet of Things, where at the time it is very interesting because it was fully proprietary world with proprietary protocols. And that was hard, I can tell you, because we had a lot of resistance from the field, from obviously these industries protecting their proprietary stuff. So I could design some new protocols now that are deployed with, on hundreds of millions of nodes. So that was another one that was fun to do because, I moved from service providers to these little tiny pieces in the Internet of Things. And then, what I wanted to do was to think about how we could innovate fast with a very big company with the power of Cisco And that's something very unique in this company that I really love. This ability to have the power of a big company and still act as a sort of internal startups when you can really come up with new technology. So this is where I started with ML AI for the network. And so we did something called self-learning networks. It was about using machine learning for security, detecting some exfiltration attempts and all those things. Then we invented something brand new for wireless, which is known as Cisco AI Network Analytics. And then I moved to this new technology we're talking about today, which is Cisco Predictive Networks. But the one thing that I would like to say, AB, and this is the one advice I would give to younger engineer, is not everybody is designed, I would say, for innovation.
Right.
If you ask an engineer, everybody would say, of course, I want to do innovation. But if you want to do innovation, you need to be comfortable about not being comfortable. You need to move outside of your comfort zone.
Right.
And this is what I did many times. I can tell you, many times I stopped working on a technology that I could really master, I would say, and I moved to another area where I was a complete newbie. I knew nothing about it, absolutely nothing.
Right.
And then you start again. And this is fun. I mean, this is great journey. If you really want to move, again, move, but don't wait for people to do that.
Right. And speaking of young engineers, I know you've mentored a lot of people over the years. I'm always amazed, technology-wise, as to how quickly we advance. Just when you think we've hit the pinnacle, a new technology or a new approach to tech comes out, and you're just blown away. Is this the best time ever for young engineers to get into the field?
Yes. You know why? Because for many reasons. First of all, when you look at the past 5 years, the cloud as being an absolutely incredible new area, I would say it has changed so many things. And of course, it opens door for new innovation. So I think this is one thing that I would mention. The second one is the importance of data. And this is very interesting. You know why? Because if you look at 10 years ago, we used to look at data as a way to troubleshoot. It was always an afterthought. And now you look at what you can do with data, really understand what's going on.
Right.
And when you look at that kind of technology, how to use data with machine learning and artificial intelligence, you can do so much more compared to what we've done in the past. And so that's why it's absolutely an amazing time to join not only a company like Cisco, but also to work on this kind of new technologies. Yes, it's a great time.
With all this talk about predictability, predictive networks, it's no surprise because I know how passionate you are about neuroscience and the brain in particular. What is the connection there between how we think as humans and this predictive networks technology that you guys are creating?
Yeah, what an interesting question, AB. On a personal note, I would say that I've been always passionate about neuroscience, and there was no connection, to be frank, with this project and the fact that I was working on machine learning, artificial intelligence at Cisco. It turned out that, again, it was a pure coincidence. And at some point, I started to see some connection between the two for some reasons. And I think that the topic of predictive networks or predictive engine turns out to be very interesting from that point of view. So let me explain why.
Okay.
We don't know exactly how the brain learns. We know stuff about synaptic plasticity and neurogenesis and all those things, but we're not quite sure how a young baby would learn.
Right.
And if you look at driving cars and things like that, which are using what we call supervised learning, you need to show millions of examples, right? If you want to train a camera to recognize a car, you need to show millions of pictures of a car. When you do that with a baby, you just show 10 cars and then you know that it is a car. How can it be possible? So that we don't really understand yet. There are some hypotheses. There's another area which is about being able to predict. So I'll give you some examples. Do you play tennis, AB?
I do. I was much better when I was younger, but I love tennis.
Okay, here we go. So I'm going to take that example, and then you'll never play tennis the same way after I'm going to tell you that. But you'll see.
Okay.
It takes a few hundreds of milliseconds when the light hits your retina just to process it. Or maybe you have an amazing brain, and it's probably the case, but still, for a normal human, it takes a few hundred of milliseconds. What does that mean? It means that the ball is already a few meters out.
Yep.
So what that means is that when you start, you want to hit the ball, you need to predict what will be the path of the ball. You live in the past. That's another way to look at that. When you grab a cup of coffee, look next time at your hand. Your hand anticipates the shape of a cup, right? So what we believe is that the brain is capable of learning thanks to the ability to predict. And I don't want to take a too cheap analogy, but we came up with a logo of a brain with where we highlight the areas of the brain involved in the ability to predict. And that's why you've got this fun logo that we use internally sometimes about predictive networks, because this is exactly what we do. So I would summarize in one sentence. Well, let's say two. One is when you look at the human brain, you build a model of a world. And that's why when you close your eyes, if I tell you, imagine maybe you're in the mountain and you want to ski, you see yourself skiing, right?
That's right.
So why? Because you built up a model of the world. What we do with Cisco Predictive Networks is we build a model of the internet. And we're not using eyes and ears, we're using telemetry. But we still use a model of a network fed by telemetry. And then we use some mathematical models to predict what will happen, which is exactly what you do with your brain as well. And then you plan. And this is going to be the next step for us, which is about self-healing networks, where the network is capable of making some prediction and acting and then correcting his own action. And this is what is coming next as well. In the brain, you do that here in the prefrontal cortex, just above your eyes. This is the area in charge of planning. That's what we're going to do with Cisco Predictive Networks and predictive networks in general.
That's amazing. It's hard for me to grasp because the technology is way beyond my capabilities, but it really makes sense when you make those everyday real world analogies, because certainly I was closing my eyes, as you said, imagine yourself skiing. And you're right. We already know how to formulate these visions in our head. And if a computer can get somewhat close to that, then it certainly seems like it would be able to predict with a fair amount of accuracy, right?
That's exactly right. And then you give the ability to predict, but also correct your assumptions and stuff like that. So does that mean that we can mimic the human brain? Not at all. We just barely understand how the brain works, except for some areas like vision, we understand a bit better. Memory, we start to understand a bit better. So I'm not going to say, we have now the equivalent of a human brain.
Right.
Not at all. But still, we're making some progress because we know that we've been talking about self-healing networks for a decade. This is hard to do, but we are making progress. And I think we're just scratching the surface. Back to what you said about young engineers, is it the right time to join? Yes, it is.
I hear that.
Right.
I hear that for sure. Let's shift completely in a different direction. I want to talk about where you are in France, which I've never been to, unfortunately, but I will make it out there. I have several friends from France who, like me, are musicians. You're in France, obviously a very rich artistic history in general. Are you passionate about art or even music? And if so, who are some of your favorite artists when you're looking to unwind and listen to something for inspiration or just to kind of be in a great calm state?
So the short answer is yes, I absolutely love music. I've been playing piano for some time.
Nice.
Until I realized that I was a really bad piano player. And then I started to do some drumming as well. My son is an amazing saxophonist. So yes, we love music at home. And the reason why I love music so much, by the way, is probably because of the art of improvisation. So since you mentioned some artists, I would absolutely mention Keith Jarrett.
I love Keith Jarrett.
We traveled around the world because, as you know, he used to do, I say used to, unfortunately, but he's still alive, but he doesn't play anymore. But once a year, he would give a solo, and it's just magic.
Yeah.
To me, it's absolutely magic. So I've been to the Carnegie Hall in New York many times to see him, and absolutely amazing guy. And of course, Chick Corea.
Yes, one of my favorites.
Mm-hmm. Oh, you love him as well?
Oh, I love Chick Corea. Yep.
Here we go. Grover Washington. Probably as well.
Grover Washington Jr., Oscar Peterson, pretty much. Yeah, I'm pretty into jazz myself. I'm a drummer, and I love jazz drumming, but I also love pretty much everything. But I love those guys, and many more, so many more, right?
Oh, yes. You probably love Gadd, Steve Gadd, right?
Yes, Steve Gadd, amazing.
Yeah, right? What I'm realizing, though, is that I keep mentioning American artists. And I can't think of jazz is in the US, right? There's nothing you can do about that. But there is something unique about France, which is about cuisine and gastronomy. So that's something that is still a bit unique. So you guys have some amazing wines, if I may say that the gastronomy is still very amazing in France.
Absolutely.
Yeah. Okay.
Yeah, I don't think anybody would argue with that. I mean, that's pretty much a given. And yeah, we have some good wines, and the food is obviously getting better, and it depends on where you go in the States. But I think France is still it set the benchmark, and I think that's what most modern chefs who are really learning the craft, I mean, they at least have some French training. It's a must. It's a fundamental that you can't not have if you're going to call yourself a chef, right?
Absolutely. So next time you go to France, we're going to combine music and food.
I love it. That's right up my alley. I'm good to go. Well, JP, I know that we could probably talk for another 3 hours, but I've had such a great time talking to you, learning about predictive networks and all the other things we discussed. I just want to thank you again for having a chat with me today.
Thank you, AB. It was nothing but a pleasure. I'm just hoping that the people listening had a really good time as well. So thank you for your time.
You're welcome. Thank you.